Hello, everybody. Congratulations to you on completing paper 2 of the Tuition Centre 2024 Leaving Cert Higher Level Maths Pre. My name is Owen O'Leary. Let's go through the solutions to this paper. So we start off here with, of course, question 1, which is one of our 6 short questions. It's your best 5 from 6 short questions this year. And with your long questions, it's your best 3 from 4. Okay, let's have a look. So this first question is an interesting one in that I know some of you skipped this question. I know that some of you looked at this at the start and said, no, I don't get it. And in fact, I know some people have kind of decided that they don't like these kind of Venn diagram probability questions, conditional probability, because they feel they just don't quite get it. They can't be sure. However, I'm hoping to show you here that it's worth your while practicing these questions, because even do this. Look at the length of time that this video takes and compare it to the length of time the other videos for paper 2, the short questions take. And this is going to be the shortest, even including my intro, because it's all about understanding. If you can understand these, it's so quick. The marking scheme, the amount of, kind of lines in the marking scheme for this are so short. Okay, let me get on with it. For the events A and B from a sample space, the probability of A given B is equal to 3/4, and the probability of B is equal to 1/3. And you're asked to calculate the probability of A intersection B, which is the probability of both A and B occurring together. So in this case, you have to know about conditional probability, and you need to know the formula. Now, is that formula in your table book? The answer is no. But where it is on the formula sheet that I give to everybody, called Formula Not in the Table Book. And it's on the website if you haven't downloaded it yet. Okay, let's have a look. So as I said, what's vital about this is that people, are fluent in the language of conditional probability and Venn diagram probability. So our formula is this, which again is on that sheet I mentioned. The probability that A occurs, given that B occurs, or given that B has occurred, is equal to the probability of both A and B occurring over the probability of B occurring. Now, again, some people will go through their life without ever fully understanding that formula. That's all right once you know it, because then you can just fill it in. Okay, we know that the probability of A given B is 3/4, so we can fill that in on okay, I'm actually going to multiply across here, but I could fill that in here. The probability of A given B, I can fill in the probability of B, which is 1/3. Okay, and then I'm going to just find what I need, which is the probability of A intersection B, A and B occurring. So in this case, I've multiplied across and kind of got everything ready. So it is going to be my 3/4 for the probability of A given B, multiplied by my 1/3 for the probability of B, and that's the only maths. It's a quarter, 1/4, and that's 10 marks. So for the person who knows it, it's a piece of cake. For the person who doesn't, it's impossible. Calculate the probability of A complement intersection B, where A dash, right? A dash denotes the complement of A. Now, this is bringing it back to like maybe the very first thing you learned in first year, sets, when you went into first year in school. And we have to remember what A complement is. A complement is everything in the universal set, so we could call this the universal set, that does not include B. Okay, that does not include A, I should say. So A complement is basically all the part in green. Intersection B, well, we know what B is. B, of course, is the entire circle B. So if we're looking for the intersection of those, well, it's not going to include and when I say the intersection of those, I'm saying the intersection of A complement and B. Well, it's going to be that part there. Okay, it's not going to include the overlap between A and B. Okay, so it's not going to include the overlap between A and B. And just to clarify one thing like that, now is just representing set A. Just the A dash was there at the start to show you what A complement meant. So that green section represents A complement intersection B. And how we calculated it is you work out the probability of being in the entire circle B, and you take away from that the probability of A intersection B. And luckily for us, that's just what we calculate up here. So it's 1/3 minus 1/4, and it's equal to 1/12. So the probability of being over in this region is 1/12. The probability of being in the intersection is 1/4. So then that allows us then to do our last part of the question. And we're up to 20 marks already, but our last part then is if events A and B are independent, calculate the probability of A union B. Now, we're back here, right? And we're looking at this and we say, okay, we know the probability of B is 1/3. We can see the probability of like B only, we'll say B less A is 1/12. The probability of A and B occurring is 1/4. We're not quite sure what's in here because we're not sure what the probability of A is. But again, this brings us back to just our understanding of it. That if events A and B are independent, calculate the probability of A union B. Well, if A and B are independent, then the probability of A occurring, given that B has already occurred, is the same as the probability of A occurring, which means that the probability of A occurring is just going to be 3/4. Now, just why is that? Because if they are independent, B occurring has no influence on the likelihood of A occurring. So therefore, the probability that A occurs, given that B has occurred, is the exact same as the probability of A occurring. So therefore, the probability of A occurring is 3/4. So if I just go back to here now, the probability of A occurring is 3/4. So therefore, if 1/4 is in the overlap between A and B, then 1/2 is the probability of A occurring but not B. So here we go. The probability of A occurring is 3/4. The probability of B occurring is 1/3. We knew that from the very start. The probability of A union B occurring is minus 1/4. So all we have to do this is put those together and we get our answer of 5/6. And that's going to be our last 10 marks. Now, some of you might think, hold on a second. We know that this formula only works if A and B are not mutually exclusive. But we're not told that in the question, but we know it because what it means to be mutually exclusive is there will be no overlap between A and B. But we have found in the very first question that there was an overlap. The probability of A intersection B is 1/4. So when we want to go back, and if I just go back to this slide, because I am conscious that sometimes people find this tricky, that when we're talking about just A and B, if we say the probability of A union B means the probability of being in A or B or both. So it's that section in orange. But if we want to work that out, we work out the probability of A, we add on the probability of B, but we must subtract the probability of A intersection B because otherwise that would be double counted. And we know for sure they're not mutually exclusive because, as I said, we knew that A intersection B is 1/4. So my answer is 5/6. And I hope you can see that, if you understand it well, is the shortest question anywhere on paper 1 and paper 2. And it will split the class and the people who did this right down the line. Loads of people doing very well and loads of people doing very badly. So I hope I've convinced you that it's worth learning this one. Okay, let's move on to question 2, a very different type of question.